Hi everyone. In this video I'm going to tell you about how to extract data from a figure using the program metaDigitise. So here I have an image of a figure that I've extracted from a paper, and I want to be able to get the means and standard errors out of this figure so I can use them in a meta analysis. So the first thing I'm going to do is to create a folder. It doesn't matter what name this directory has. I'm going to call it figure, and I'm going to put my figure into this. So I'm going to put all of the, if I had more figures that I wanted to extract data from, I'd put all of them into this directory here. But for now, I'm just going to show you how to do one with one image. So now I'm going to start up R. Use the terminal to run R, and I'm going to load in the metaDigitise library, and then run the function metaDigitise. And what I'm going to do here is I'm going to create an object called data, which the metaDigitise function is going to save the extracted data into. So what I give to the metaDigitise function is the name of the directory, and then I run it. And because this is the first time I'm running it, and what I want to do is to extract new data from images, I'm going to select this first option, process new images. So now it's going to ask me about whether the plot types are different or the same. Here I've just got one figure, so I can choose S for the same. And then it's going to ask me about what plot type. So metaDigitise can process different types of plots, and this is a mean and error plot. So now in the plotting window, it brings up the plots for us to interact with, and at the top here, it's telling us which figure we've given it. So this is nicely orientated, so we don't need it to rotate or flip the image. So we can choose continue. It's now going to ask us various questions about the metadata of the image. So the Y variable here is X size, and it's now going to ask us to calibrate the Y-axis. And it wants us to click on 2 points on the Y-axis to help it calibrate it. So here I'm clicking on 2 known points at 38 and 46, and then it's going to ask me what these values are. So I put that in, and then it plots it onto the figure, so I can see that I've done this correctly. So I'm happy that this is a good calibration. So I can choose no here when it's asked me if I want to recalibrate it. So if I'm doing something like a mean error plot, it's useful to be able to put the sample sizes in, so the standard errors can be calculated to standard deviations, or vice versa, or confidence intervals can be made into standard deviations or standard errors. If you don't know the sample size at the time at which you're doing the extraction, you can always go back later and put the sample sizes in. But we do know the sample sizes here, so I'm going to select yes. And in this image, there are multiple groups. So here there's 6 groups that I want to extract data from. And if there's multiple groups, then you can name them, and this naming comes out in the output. So I'm going to name the first group. And in this image, I know that the black dots are from fed individuals and the white ones are from unfed individuals. So I can name this first group fed 2004. It's going to ask me the sample size. So this is this group, and we know the sample size is 11. And now I have to click on the error and on the mean, and now it's imported that data. So it now gives me various options to add another group, to edit that group if I'd done something wrong, to delete it, or just to finish. So I'm going to add another one. So now I'm going to do unfed, also in 2004. here we have a sample size of 10. I can now click on the error bar and the mean, and let's import that data. So let's do now 2005, do fed 2005. This group has 60 in it, so I can now click on the error and on the mean. You can add unfed 2005. This has 66, and again I can click on the error and on the mean. So now, for now, I'm going to finish this plot. For example, perhaps in this situation, I don't want the data from 2006, so I can click finish. It now asks me what sort of error, as in this mean and error plot, and in this case, it's the standard error for SE. And now it gives me a message telling me that I finished all of the images in this directory. If I'd had more figures in this, it would have moved to the next image. Let me digitize that and then moved on to the next image and cycle through all of the images in the directory. And you can leave at any point and it will save the information that, that you've done. So if we now look in this directory, it's created a folder called cowdat, and in that folder it's created a file that relates to the image that we put in. And this file here contains all of the data, all of the calibration data used to make this figure. So we can recreate our extraction from this data. And this means that you can share this folder with all of the figures in it and the cowdat folder in it with anybody. They'll be able to run metaDigitise on their computer and completely recreate the data extractions that you've done. So at the beginning, I created this object called data and saved the output from metaDigitise into this object. So let's run the data and see what this comes out with. So here you can see that it exports the file name, the variable that we gave it, the group IDs that we gave it, the means, the standard deviations and sample sizes, and some other information. So that's a very easy way to get this data. But now we might want to go back and we've now decided that we also want the data from 2006. And what we can do is we can edit this extraction. So if we run this code again, we again run this metaDigitise function. And now instead of processing new images, we don't have any new images. We want to edit the existing data. So we now pick number 3, and we can choose different options for what we want to edit. We can either cycle through all of them, and this enables someone to look through all of the data extractions and make sure they look okay. We can choose a specific file to edit, so that's more relevant in this case. And as I mentioned before, we can go back and enter sample sizes that we didn't have the information for at the time of doing the data extraction. So I'm going to choose number 2, and then I'm going to select the image that I want to do. In this case, there's only one image here. And now it's going to take me through the whole process for this image again. So I don't want to do the edit the rotation. I don't want to change the plot type. I don't want to change this. I don't want to change the calibration. I do want to re-extract the data. So now it takes me back to this option where I can add, edit, delete, or finish the plot. So now I want to add some plots. Here we're going to add in fed 2006. This has 19 individuals. And here we can click on the error bar and the mean. And then we can add the other one. This one was unfed 2006. This also has 19 individuals. And here we can click on the error bar and the mean. And now we can select finish the plots. And we don't want to change the type of error, so we select no. We don't want to edit any more files, so we select no. Now we can go back to our data object, and we can see that fed 2006 and unfed 2006 have been added in. So now we have the mean and the standard deviation for all of these groups for this figure. So if we had more figures in this folder, then we would just have more, we'd have different file names, the groups that we'd input in, and a lot of means and standard deviation. So everything would be included in the same data frame here.